Okay, welcome once again to another wonderful episode of Brainwaves Academy online tutorial. Now, today we're going to be talking about a fantastic topic, which is the complex number. The complex number, right? Now, what are complex numbers and how can we apply complex number at the end of the video? At the end of this video, you're going to find how to use the conjugate of a complex number, how to use them to solve quadratic equation, find the modulus of a complex number, and find the argument, including the principal argument of a complex number. Now, you understand that if you want to solve equation in the real plane, what I mean in the real number system, you can solve equation of the form x squared minus 1 equal to 0. In this case, all you need to have is x squared is equal to 1. Then subsequently, you can take the square root of both sides. You can take the square root of both sides, then you're going to get x is equal to plus or minus 1, right? Because square root of 1 is 1. Now, the question arises when you want to solve any equation of the form x squared less than 0, or you are solving the equation of the form x squared plus 1 is equal to 0. Now, if you look at this, you will discover that you have x squared is equal to minus 1. So therefore, if you take the square root of both sides, what you are going to get is x squared is x. If you take the square root of both sides, you are going to get x squared is equal to square root of negative 1. Good. So by so doing, you have come to a point whereby you have a negative under the square root sign. So this brings us to the concept of complex number. So square root of negative 1 is I, right? Where I is the imaginary part of the complex number. Good. So if you have x, which is in the real plane, right? The x here is an element of the real number, but you're trying to look for equation to satisfy values to satisfy this equation. You can only get them in the complex plane. So therefore, I squared is the same thing as the square root of negative 1. Alternatively, you can say that I is equal to, take the square root of both sides, I is equal to minus 1. Good. So by these definitions, these are what we are going to be using, in all of our solutions for today. Good. So that is what you are going to be using, right? You have that square root of negative 1 is equal to I squared, or you can basically use this definition over here. I is equal to minus 1. Good. So it is sometimes called an imaginary number, but this should not be taken literally, as all numbers are imaginary, right? Good. Now, basically, how do you see complex number? A complex number is an expression of this form, z. Z is equal to a plus ib, right? This is the real part of the complex number. This is the real part. Why this part is called the imaginary part, right? Imaginary part. So you have the real part over here and the imaginary part over here. Similarly, you can find it as z is equal to x plus iy, real part, imaginary part. Good. So in the number system, complex number You can always see them indicated like this. Now, so the real part of this particular number, if I want to look for the real part of this particular number, in my case here is equal to A. And then if I want to look for the imaginary part, the imaginary part of this particular number here, then it is going to be B, right? This is the real part, while this is the imaginary part. Good, fantastic. So I can have two complex numbers. For example, I can have two complex number. Z1 is equal to 2 plus 3i. I can have another complex number, Z2, which is equal to 2 minus 3i. So the real part, the imaginary part of Z1 is equal to 3, right? The real part of Z2 should be equal to 2, and so on and so forth. I can add Z1 and Z2 together, and they should give me 2 plus 4, 2 plus 2, which is going to be 2 plus 2, right? Then plus I into 3 plus 3 plus, then here is minus 3, right? So this is going to give me 4 plus I into 0. So automatically, we have the imaginary part here to be 0, while the real part here to be 4. Fantastic. Now, we can now work with other examples to see how to maximize the concept of the imaginary part. For instance, let's take some over here. If we have the square root of negative 81, then this automatically becomes the square root of 81 multiplying the square root of negative 1. We know the square root of 81 to be 9. And what is minus square root of minus 1 is basically I. Good. Similarly, we can take the square root of negative 12. This is going to give me square root of 12 multiplying the square root of negative 1. This is going to give me square root of 12 should give me the square root of 4, the square root of 3, then we have the square root of negative 1. Now we know the square root of 4 to be 2, square root of 3 can remain. We can break that down. The square root of negative 1 is I. I think this concept is fantastic, right? Let me give you more examples. Square root of negative 144 should be the same thing as the square root of 144 multiplying the square root of negative 1. This is going to give us 12i, right? Square root of 144 is 12. Square root of negative 1 is I. Now we can still go further. This should be the square root of negative 144, right? Square root of negative 144, 144. Now, similarly, let's have the square root of negative 27. This should give us square root of 27, and then the square root of negative 1. Good. So 27 is the same thing as square root of 3, multiplying the square root of 9, and the square root of 1. This should give us 3 root 3i. Fantastic. So, like I said, we can multiply complex number. For instance, let me use this particular part to give a generalization of addition of complex number, right? So if I want to add complex number, for instance, I have if I have my Z1 to be equal to A plus IB, and I have Z2 to be equal to C plus ID, then in general, if I want to add Z1 plus Z2, all I'm going to have is A plus C, right? The real parts, I'm going to add them together, then plus, in bracket, B plus D, right? So these parts, they are the imaginary parts, right? So if I want to subtract, right? If I want to subtract, so for subtraction, it's just going to be very, very similar. We have Z1 minus Z2. Then this is going to be A minus C, then plus B minus D. Then you have to be very careful of this sign, which we have done an example over here. Good. So then we can go to multiplication. Multiplication of complex numbers, right? So to multiply complex number, I can have Z1 multiplying Z2. Then we're going to be having A plus IB, right? Multiplying C plus ID. Fantastic. So here we're going to be getting, let's do them pairwise. You're going to A multiplying C. So you're going to have AC. A multiplying ID. You're going to be having plus AD. This is imaginary. Then this multiplied by this, you're going to be getting plus BC with the imaginary. Then this multiplied by this, you're going to be getting plus BD. Then your I is going to be squared, right? I squared. Good. So what is I squared? What is I squared? I squared, can you remember? I squared is -1. So here, let's add this term together. We have AC plus, over here, I'm going to get AD plus BC. Now these are imaginary I. Then here, remember BD, but our C becomes -1. So we are going to be getting AC plus AD plus BC, while here we're going to be getting minus BD. So we can take this to this part since they are all real part. So we have AC minus BD plus AD plus BC. Now this becomes the imaginary part. Then this become the real part. Now you can see that this is very, very simple. Very, very simple. Good. Now let's see if we can now take some more examples before we go order to the next section of this video. Good. Now, for example, if I have Z1 to be equal to 2 plus 3i, and I have my Z2 to be equal to 2 minus 3i, right? Let's see if we can get Z1. We have added them before, so let's go to Z1 minus Z2. Now this is going to be what? It's going to be 2, right? 2 plus 3i minus 2 minus 3i. Fantastic. So here I'm going to be getting 2 minus 2, which is the real part, right? Then I'm going to be having plus 3. Then we have 9 minus minus here will give us plus 3i. Fantastic. So here 2 minus 2 is 0. Then 3i plus 3i is going to be 6i. Good. So the imaginary part of z1 minus z2 is equal to 6i, while the real part is 0. Now, similarly, you can be asked to get 2z1 plus 3z2. So this is going to be 2 into z1, z1 should be 2 plus 2i, that's z1 plus 3, z2 is 2 minus 3i. Fantastic. So this is going to give us 4 plus 4i. This is going to give us plus. So we have 6. It should give us 6 minus 9i. So if I'm evaluating all this, I'm going to be getting 4 plus 6, which are the real part. Then I'm getting plus 4i minus 9i. So this is going to give me 10, while here I'll be left with minus 5i. Minus this and this should give me, this and this should give me 4. This and this 4. Then I have 3, 6. Then I'm going to get 9 over here. Right? So I have 4 and this should give me negative. We have 4 and then we have 9. Let's see, 6. This should give us 9 basically. So you can check, you add the real part together and then the imaginary part together. Fantastic. So this is plus 4, then this should give us negative, right? This should give us a negative. Good. This should give us negative. So this should be negative 5, right? I, which you can check to see if you are accurate about that. Now we can move on to more example. Let's multiply 2 plus I multiplied by 3 minus I. Good. So here we're going to be having 2 multiplied by 3 plus 2 multiplying minus I, then plus we have 3 multiplying I, then lastly we're going to get plus, we have I, then we'll have minus I multiplying each other. So here we're going to be getting 6 here minus 2I here plus 3I. What about here? We're going to be getting minus, then we're going to be getting I squared. Fantastic. So what is I squared? We know I squared is equal to minus 1, so we're going to be getting 6 plus I, right? So minus I squared is minus 1. So fantastic. We are going to get 1 plus I, then plus 1. This should give us 7 plus I. Great. So we have other examples over here, like what is I cubed, right? I cubed is the same thing as I squared multiplying I. I squared is negative 1 multiplying I. This should give us negative I. You see, so this is cool and straightforward, right? So for example, another example we have 2i multiplying 3 minus 2i. So this is going to give us 6i minus the next one is going to give us 4i squared. So what is I squared? -1. So we have 6i minus 4 into -1. So we have 6i plus 4. So it's straightforward, and it's fantastic. So let's take some that has to do with the quadratic in quadratic form. So example 1 over here, we have x squared plus 9 is equal to 0. Good. So if I want to solve this, it's going to be x squared, right? It's going to be equal to -9. We have x squared. We take the square root, it's going to be the square root of -9. So we have x to be equal to what? X to be plus or minus. So we have plus or minus square root of -9. Then -9 is automatically 3. Then multiply by I. So our x is going to be what? Plus or minus 3i, because here we're going to be having square root of 3 multiplied by square root of -1, right? Isn't that fantastic? So we also have another one over here. Let's solve x squared minus 4x plus 7 is equal to 0. I'm going to be using the quadratic formula. In our case here, a is equal to 1, b is equal to -4, and c is equal to 7. So applying the formula, I have minus, here should be minus b plus or minus square root of b squared, right? Minus 4ac, then everything should be over 2a. So applying this formula, I have my x minus b. So we have minus 4 plus or minus square root b squared is -4 minus 4. Then a is what? What is a? 1. Then c is what? C is 7. Fantastic. Then everything should be over a is 1, right? So I'll multiply it by 1. So what are we going to have here? We're going to be having 4 minus minus. So I have plus or minus square root of 4 squared should be 16 minus 4. 4 multiplied by 1 multiplied by 7 should give us 28, right? So this is upon 2. So automatically here, we're going to be getting what? We're going to be getting 4 plus or minus square root of what? Square root of -12 upon 2. We have done this before. This is going to give us 3i, right? Because square root of 12 is the same thing as square root of 4 multiplying square root of 3 multiplying square root of I. So this is going to give us 4 plus or minus 3i. 3i root 3i, right? Because square root of 12, remember, let me recall that square root of 12 is the same thing as square root of 4 square root of 3, right? So square root of -12 should be the same thing as square root of 4 square root of 3, then multiplying square root of -1. Square root of 4 should give us 2. Square root of 4, this should give us 2 root 3, then I, right? Good. So fantastic. So here, we're going to be having, over here, we're going to be having, we have 4 plus minus 2 root 3 I upon 2. Fantastic. So automatically here, we're going to be having 4 all over 2 plus or minus 2 root 3i all over 2 also. So this can go into this can go into this. We are left with here 2 plus or minus root 3i. Fantastic. Fantastic. So here, what is going to be the real part? So the real part is going to be this part over here. The imaginary part is going to be this part over here. Good. So our x1, our x, first value of x is going to be 2 plus root 3i. The second value of x will be 2 minus root 3i. Fantastic, fantastic. So we can take one more example before we go to the conjugate, right? So let's take one more example. We have x squared plus 2x plus 5 is equal to 0. Good. In our case here, A is equal to 1, B is equal to 2, C is equal to 5. Remember, so applying our formula, we have x will be equal to minus b plus or minus the square root of b squared. So we have 2 squared minus 4 into a into c, then upon 2a, right? So this will give us minus 2 plus or minus square root of what? Here we'll have 4 minus, this should be 20, right? 4 multiplied by 1 multiplied by 5 should be 20. Then we'll have upon 2. So basically, we're going to be having minus 2 plus or minus square root of 16, right? Upon 2. So basically, we're going to be having minus 2 plus or minus, but this 16 is going to be negative, right? Because we'll have we have 4 minus 20, so it's negative. So let's split it down. This should be square root of 16, multiplying the square root of -1 upon 2. What is square root of -1 is I. So we have 2 plus or minus 4i. Fantastic. Isn't that awesome? So this is going to give us a minus 2 upon 2, right? Plus or minus 4 over 2i. Then basically, if you reduce this, you're going to be getting minus 1 plus or minus 4 upon 2 should be 2i. So our x1 is going to be minus 1 plus 2i. Our x2 is going to be basically minus 1 minus 2i. How cool is that? How cool is that? Good. So by this example, we go straight to the concept of the conjugate. The concept of what we call the conjugate. Why do you need the conjugate and how do you apply the conjugate? Now, the conjugate of a complex number, if a complex number is equal to a plus bi or ib, then the conjugate is just basically a minus bi or ib. Similarly, if I have a complex number in terms of x plus iy, then the conjugate of this complex number is basically x minus iy. Good. Now, for instance, if I have x, z multiplying its conjugate. So what am I going to get? Z multiplying its conjugate, this is a plus bi. So multiplying its conjugate, I have a minus bi. Fantastic. So I have a squared. This a multiplied by a should give me a squared. A multiplied by bi, this is minus abi. We have bi multiplied by a, this plus abi also. Bi multiplying another bi. So we have minus, we have b squared, then we're going to be having I also squared. So automatically here I have b a squared. This and this can cancel out. I squared is what? I squared is -1. So I have minus b squared multiplying -1. So I'm going to be getting a squared plus b squared. Now, you can see that there is no imaginary part here. We only have the real, we only have the real plane over here. So automatically you can see that when you multiply a conjugate complex number to itself, you're going to have the real part as your result. So one important thing about conjugate is that if you multiply it by that particular complex number, you're going to have your result in the real plane. Good. So let's see if we can pick some example. Some example over here. If I have my z is equal to 6 minus 3i. So let me multiply it by the conjugate. So the conjugate will be what? The conjugate will be 6 plus 3i. So if I'm multiplying these two together, I'm going to be having minus 3i. Then I'm going to have a 6 plus 3i. Great. So what am I going to get? I'm going to be having 6 multiplied by 6, which should be 36, right? So I have 6 multiplied by 3i, going to be having plus, this is 18i, 3 multiplying 6 minus 18i, then 3i multiplying, negative 3i multiplying 3i. This I'm going to get in minus 9. I squared is plus, right? So I have I squared is minus 1. So automatically here is plus. This and this, they are all gone. So I'll be left with what? This, I should be left with 36. Then here should be plus, right? Plus 9. Good. So you can add them. You can see these are now in the real part. Good. Fantastic. So what do we have? Automatically here, divide one complex number by another is going to be the next example we are going to be considering, right? I want to divide one complex number by another complex number. So I have a complex number Z1. I want to divide it with another complex number Z2. Now, all I need to do is to multiply by the conjugate, right? So all I need to do is to multiply Z1. I'll multiply it by the conjugate of Z2, right? So I have Z2 multiplying the conjugate of Z2. You can see I have not altered this particular, this and this can cancel out, right? This is what I mean. You can see that this part of, this part, can you see this? So this part does not actually affect the original equation that we have. Does not affect the equation. You're just multiplying by the conjugate and nothing changes. So for example, if I have A plus IB, this should be dividing C plus ID. Then all I need to do is to multiply by the conjugate of this. So I have A plus IB upon C plus ID. Then I'll multiply this by what? C minus ID, the conjugate, upon C minus ID, right? Fantastic. So you can see that this part does not actually change because C minus ID divided by C minus ID is equal to 1. So what am I going to get at the end of the day? I'm going to get A multiplying C. Then I'm going to get A multiplying ID. So we have minus AID, IB multiplying C minus BC, that is going to be I. Then this multiplying this, I'm going to be getting plus. Plus what? Plus BD. Why? Because I multiplying I is negative, right? I multiplying I is I squared, and I squared is negative. That's why here is plus. Good. So in the denominator, remember when we multiply a conjugate by itself, we're just going to get C squared, then plus D squared. The middle terms are going to cancel out. We have C multiplying C squared, then C multiplying ID. This next one is going to be plus ID multiplying C. You see they cancel out. So the next one I'm going to be is D and D. D and D is D squared. I multiplying I is I squared, which is -1. -1 multiplied by this negative over here, you have plus. So this is what you're going to be getting. Right? Fantastic. How cool is that? Let's take some example. So let's take some example. Before we call it a day, we have 10 plus 5i upon 1 plus 2i. So all I'm going to do is to multiply by the conjugate of the denominator, right? So I have I going to multiply by this conjugate over here, minus 2i. How cool is that? 1 minus 2i. So I'm going to have 10 multiplying 1 is 10. 10 multiplying minus 2i is minus 20i. 5 multiplying 1 is going to be plus 5i. Then 5 multiplying 2i, we're going to be getting minus 10 I squared. Remember, our I squared is -1. So 1 multiplied 1 is 1 squared. Then 1 multiplying minus I is, let me just write it down, minus 2i. Then 2i multiplying 1 is plus 2i. Then 2i multiplying minus 2i, this is going to be minus 4, but we have I squared. Remember, I squared is 1. So here we're going to be getting 10. This and this should be minus 15i. Minus I squared is equal to -1. Fantastic. So here we're going to be getting plus, because here is -1, multiplying this is plus 10. Then we're going to be getting everything here should be upon what? Upon this, and this is gone, right? So this one, this guy over here will be 1, but here -1, because I squared is -1. So we're going to be having plus 4. Fantastic. So what are we going to be having at the end of the day? We have 20, 10 and 10, 20 minus 15, I, then upon 5. Then this basically is going to be not 4, rather, this is not 4, this is 5, right? So this should be 5. So this is 10 upon 5 minus 15 upon 5. How cool is this? So this is just basically going to be 2 this is 20, right? 10 and 10 is 20. 10 and 10 is 20. So 20 divided by 5, it should give us what? What is 4. So 20 divided by 5 should give us 4 minus 3i. How cool is that? How cool is that? It's very simple and straightforward. So if I ask you to simplify I raised to power minus 1. Now from indices, this is just 1 over I. Is that not so? Good. So all I need to do is to multiply by the conjugate, minus I. This is going to give me minus I upon minus I squared. This is minus I. What's I squared? What's I squared? I squared is what? I squared is minus 1. So this is minus I upon 1 minus I. How cool is this? How cool is this? Very, very fantastic. Very, very fantastic. Good. So these are what you are going to get when you are talking about complex number in general. Complex number in general. Good. Now, we can talk about the modulus of a complex number. Modulus of a complex number. The modulus of a complex number, right? Assuming we have complex number of this form, z is equal to a plus bi. Now, let me give us some structure. For instance, I have good. Let's say I have this line over here, right? And I have another one over here, right? So good. Now, if I want to find the modulus, this should be the distance over here, right? Pardon my drawing. So I want to get this particular point, the summation of these two. That is what I want to get, right? So let me use these, for example, I just want to get from here, if from here down to this point is this particular element that I have here. If this point is my A and this is my B, right? Now, the modulus is just, I want to get the summation over here. So this place is going to be modulus of Z, right? So this basically, the modulus here is going to be what? A squared plus B squared. That's all. So for instance, if I have, let me sketch this. So I have here to be 5. I have from here downward to be 6, right? So this point over here should be what? Should be Z, which if my Z is of this form, 5 plus 6i, then the modulus here is just very simple, which is just 5 squared plus 6 squared. This should give me what? It should give me the square root of 25 plus 61 plus 36, which will give me 61. So that is very, very simple. That is very, 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 very simple. Now, in the next class, we are going to be looking for how to get order conversion of argument to principal argument. We're going to be finding all this, using all the strategy available to simplify other parts of complex number. So I think if this is helpful to you to understanding complex number, I want you to give this video a like and please share. Then subscribe. Also, send this to your colleagues and your friends. And I will see you in the next video. You can always check the videos, the previous videos. I may leave the description in the comment section, or in the description, I may leave a link, or you can just browse through the channel and see more demystified videos on complex number. See you next time.